Sun Tao, the author of The Art of War, says, if you know the enemy and know yourself, you need not fear the result of 100 battles. If you know yourself but not the enemy, for every victory gained, you will also suffer a defeat. If you know neither yourself nor the enemy, you will succumb in every battle. I know that somebody is afraid of AI agents. Somebody finds they're the closest friend. Sometimes it's a combination of both groups. In any case, I guess you should, as well as me, be aware of the variety of agents available to better understand how to approach them. Hello, this is Julia, and we talk about human-AI interaction here. Earlier, we observed what is the AI agent, debrief the history of creation, and today we will have a look on types of AI agents. If you are an entrepreneur looking to improve the performance of your assets, or if you want to see which businesses are already using AI agents, or if you would like to find out the industry gold standards, or if you feel that variety of agents are as big as black box could be, you will find this video helpful. Before diving into the theme, hit the like button, subscribe, and stay curious about human-AI interaction. This small impact from you gives a great result in a distance for all of us, helping me to produce more interesting video here on this channel. Thank you very much, and let's go on. Of course, we understand that the same as human, AI agents can be different. Let's split them by architecture and highlight the domain and sphere where it makes sense to use it. There are simplex, reflex agents. They follow a simple condition-action rule based on the current perception, the immediate condition. For example, basic digital thermostat for heating-cooling system, or automated door in supermarket. How it works? Agent make decision based on immediate environment input, percept, and set of predefined condition-action rules, without maintaining any internal model or state or memory of past events. We remember it like if-then rule. Are widespread in energy and utility domains, best fit industrial safety and smart infrastructure. Model-based reflex agents use both the current perception and the internal model to decide on an action. For example, an autonomous robotic vacuum cleaner that tunes when it hits an obstacle. How it works? The vacuum uses sensor or camera to perceive immediate environment input. Then it goes through internal model state, what is already cleaned, layout of the room, effects of its action, updates its position on the map continuously. After the agents use its current perception, combined with its internal model, to fire a rule and select an action, condition, action, rule. Reflex. If the area cleaned, we move to another area. If not, we clean it. And then action execution. Are widespread in transportation and logistics, best fit autonomous systems and remote monitoring. For example, warehouse, cobot, collaborative robots. Goal-based agents expand on model-based agents by using a goal to determine the best action. They calculate which sequence of actions will lead to the desired state. For example, a navigation system that plans the best route to a destination, or a flight booking system that balances low cost with shortest travel time. They works the same, but additionally compare results and propose the best of top 3, 5, X options for you. Are widespread in software engineering and DevOps, best fit project management and strategic planning. Utility-based agents, similar to goal-based agents, but they use a utility function to choose among multiple options and goals or paths. The utility function measures how happy the agent will be with the state for allowing the trade-offs, for example, speed versus safety. AI system that chooses an action by evaluating all possible outcomes and selecting the one that maximizes its utility function, which is a numerical measure of an agent's happiness or desirability of a given state. This is an essential when an agent must balance multiple, often conflicting objectives in an uncertain environment. The best, or one of the best, real-world example of a utility-based agent is self-driving car. A self-driving car must constantly make complex decisions that go beyond simple rule following. It must weigh trade-offs between different goals simultaneously. First is safety, minimizing the probability of an accident. Second, speed and time, minimizing the travel time to the destination. Third, comfort, minimizing sudden braking, hard acceleration, sharp turns, force. Fuel, energy efficiency. So minimizing gas consumption or battery drain are widespread in finance and high-frequency trading. Best fit, resource optimization. Learning agent. Learning agents have a learning element that improves their performance over time. They can analyze their actions and environment feedback to adjust their rules, model, or utility function. The classic example of a learning agent is spam filter that learns from our feedback. Learning agent is an AI system designed to improve its over the time and its performance by adapting its behavior based on past experiences and feedback from its environment. This makes it ideal for complex, changing environments, are widespread in cybersecurity and threat intelligence, best fit, dynamic user environments, and R&D. Of course, agents or combinations of them can be used in many different spheres. For example, education, healthcare, telecom, data, energy, manufacturing, real estate, whatever. What industry solution would you prefer to add here for the usage of AI agents? Share your idea with me below in the comments, please. Let's divide agents by operational scope and see which domains and areas are already benefiting from its usage. Reflexive agents, the Doers. These agents are the gold standard for environments where latency must be zero and rules are absolute. These are your automation tools. They don't think about why. They just execute a command when a trigger is hit. Second, deliberative agents, the planners. These agents have a map of world and goal. They can look ahead to see if an action will help or hurt their objective. Are widespread in transportation and logistic domains, used by logistics software, warehouse robots, chess AI. Third, adaptive agents, the Evolutionaries. These are the modern AI models we see today at 2026. They are not programmed with a fixed set of rules. They are programmed to learn the rules. Best for recommendational agents like Netflix, YouTube, large language models like Gemini, and fraud detection system. Agents can be split by autonomy level, the driver matrix. This mirrors the Society of Automotive Engineers SAE levels for self-driving cars. It's the gold standard for legal and compliance teams to determine who is liable for agents' mistake. Here we can split it into these three categories, like assisted, Copilot, where the agents provide the suggestions but taking zero actions. Supervised, like human in the loop, agents plans and executes but pauses for human gates at high-risk steps. And autonomous, like full agentic systems, where the agent completes the entire end-to-end goal without any human oversight. We can split agents by interface scope, the operator metric. This split agents by how they interact with the world. It's a gold standard for IT and engineering team. Here we can split it into surface level, like UI interaction agent, which uses computer vision to click the button and type in apps just like a human. And backend level, API, tool using agent. It connects directly to databases and software via code, APIs, much faster and more reliable. We can split the agents by organizational role, the workforce metric. This treats agents as digital employees. It's the gold standard for HR and operations to treat agent correctly into the org chart. Here we can split agents by such categories as specialist and generalist. Specialists are niche agents which are experts in one narrow niche, like tax agent or some special like coder agent, and generalist like orchestrator agent or manager agent, which can split the problem into small tasks and assign them to specialist agents. Also, we can split agents by knowledge source, the intelligence metric. This determines where the agents get the truth. It is the gold standard for data privacy and security. We can split them into closed knowledge, like standard LLM agents, which relies only on its pre-trained data, where it's learned like in school, and ground knowledge, like RAG-based agent, looks up your private files, live web data before answering to ensure accuracy. By temporal logic or the memory metric, we can define how is the agent views time. Here we can split the agents into categories: ephemeral agents and persistent agents. Ephemeral means session-based agents. They forget everything when you close the window with a chat. And the persistent or episodic memory agents, they maintain a long-term user profile which keeps the information based on your profile and remembers your preferences over the months, over the time. So in this video, we talked about AI agents types. We split them by architecture, by operational scope, by autonomy level, by interface scope, by organizational role, by knowledge source, by temporal logic. We ran through economy sectors, domains, and spheres where usage of AI agents is gold standard. This knowledge brings clarity on understanding of the basic things that form the foundation for building a better future. Thank you for watching and see you next video.